So blockchain and I have been working on Newton. The big question we want to answer is, what if we put a physics engine on chain? For those unfamiliar with physics engine, it's basically software that provides an approximate simulation of physical systems. And that's basically Newton once you put it on chain. With V0.1, it's a very simple demo where we throw balls at a surface. We use PyBullet. We'll get to a demo a bit later with blockchain. And PyBullet is basically this Python physics engine. We can specify aspects of the ball, such as mass, size, position, and throw it on there. With future versions, you could imagine, the core idea here is like, what if physics have like real world value? So you could imagine balls with different sizes, maybe depending on how much ETH you actually deposit. So you could have a huge ball, incentivize certain things, etc. Now, the big question is, why is this so sick? Well, physics engines bring physics to the digital world, right? And as we move increasingly into 3D spaces, physics engines are key. And we believe that just like in the real world, it is a primitive needed to unlock complex life on top of it. So we think it's a primitive for complex, autonomous, and digital physics. And complex because they can really mirror reality. And this happens because we're basically running physics engines in a verifiable manner, right? And that's how we get to complex life that basically runs autonomously. So some basic use cases could be something like a 3D art canvas as we move from balls to other shapes, to other colors. So you could imagine kind of this multiplayer 3D canvas where people can throw or place objects. Sort of a Rube Goldberg type machine, if you're familiar, or a mousetrap, where you have a chain reaction happening, could be also one of the outcomes. Of course, gaming is most commonly what one thinks about when we think about physics engines. So this could unlock, more complex games. This is a very simple one where you just shoot a ball at a basketball hoop, but you can go much further than that. And obviously, a lot of things such as the physics could also be controlled, right, by a DAO, or could be evolving using an LLM. We were thinking of a few additional concepts such as, physics puzzles, where you actually simulate reality to solve real issues and can verify who actually solved those issues on chain. Complex physics-based turn-based games with financial incentives. Maybe you push a ball off of the surface and actually absorb its energy and value. And finally, a base primitive for autonomous virtual worlds, which is what I touched on before. Now to the actual demo, I'll give the mic to blockchain and some explanation on the technical side.
Yeah, so the demo is very basic. It's running in host mode. It's using PyBullet, and we're using the console to send in inputs on the sort of objects that we want to inject into the scenes. So we have our position that we have in here, our mass, velocity, and our radius. And every time you get an input, the simulation is basically ran for 5 seconds. So you can think of it as a turn-based sort of sandbox for now, but it could run in many different ways, right? And as for the output, we visualize this locally, right? So it's running on my machine for now, right? But it can, it can run in a whole bunch of different ways, right? Yeah, so the next steps are obviously to get it within the machine, right? And then create a state that the front end can query, right? So yeah, for now, this is just a demo to convey the idea to you. Let me share my screen and just run it live so you guys can see. This is the little POC, right? And this is our scene that's obviously running on my machine, but it can easily run within the VM. This is just for demo purposes, right? So we have a blank scene, and what we want to do is add some energy to it, right? So for now, there's no ETH value associated to the energy we add in, but eventually, like when you inject a sphere into the scene, it can have a cost based on the mass, the velocity, and the other stuff. But for now, let's add an object into the scene, right? So let's add a sphere with position here, velocity of 0, 1, 0, and then mass of 10. And then when we press enter, it's gonna run for about 10 seconds and then wait for the next input, right? And eventually inputs can be more than just adding an object. You can also apply forces to existing objects. So as you can see, we just added this sphere here. It's in here, let's add another one to try and hit it. And the next one that we add, let's increase its mass. And let's increase the radius maybe as well. And then let's give it a negative velocity so it goes to the ground faster. And yeah, let's do this, run this again and see what happens. So you can see it's falling, and then yeah, I just hit it. So yeah, now this is just a simulation, but again, there could be a game associated with this, right? Where like the objective is to maybe hit spheres off the map, and then if you hit them off the map, maybe you can accumulate ETH, right? And then that can make your ball grow bigger, maybe. Right? That could be a game, right? The possibilities are infinite. So let's just add one more, a smaller one, and then we'll just call it a day. 0. Oh yeah, this is in local, so you can see the inputs, right? And now our small one is coming, yeah, and that didn't do anything. So it just ran for 5 seconds and then it stopped, right? So yeah, that's the little game